Mathematics Class 8th, Chapter name Understanding Quadrilaterals, Exercise 3.3, Chapter 3rd, Question number 1st. Given parallelogram ABCD, complete each statement along with the definition or property used. So in this exercise 3.3, we have studied about parallelogram. That is, what a parallelogram is and its properties. Based upon that, we would try to solve these 4 parts. So we shall explain the properties that we have studied when we encounter a particular question. Let's move to first part. It says AD will be equal to what? So here we are given with the parallelogram, namely A, B, C and D. These alphabets denote its vertices. So let's focus on side AD. So this is AD, and we have studied in this exercise that a parallelogram has equal opposite sides. So which side is opposite to side AD? It is BC, that is side facing to AD. So it is BC, therefore we wrote BC, and the reason is opposite sides are equal. Similarly, if the question would be like this, which side will be equal to side AB? It would be side DC. So we have 2 pairs of opposite sides in a parallelogram which are equal to each other. With this, first part has been solved. Let's move to second part. It talks about angle DCB. Again, we have redrawn this parallelogram here, so we have to focus on angle DCB. So DCB, it's talking about this angle. Again, in this exercise of parallelogram, we have studied that a parallelogram has opposite equal angles. Therefore, the angle facing to this angle is this angle, which can be named as angle DAB. And the reason being opposite angles are equal. Similarly, the angle equal to this angle D will be equal to angle B. Again, we have 2 pairs of opposite equal angles in case of a parallelogram. That completes our second part. Third part says OC will be equal to what? So we have redrawn the parallelogram for a better understanding. Let's focus on OC. So this is OC. One more property that we have studied in case of parallelogram is that diagonals bisect each other. By bisect we mean it divides it into 2 equal parts. So therefore, this OC will be equal to OA. Therefore we wrote OA, and the reason being diagonals bisect each other. Similarly, OD will be equal to OB. That's why we have represented with 2 parallel lines. The important point to note is that these 2 different diagonals bisection need not to be equal. That is, OA will not always be equal to OD. It may be cases when we talk about squares, but not in case of every parallelogram. But one thing is for sure, that a particular diagonal is bisected by another diagonal. That completes our third part. Moving on to fourth part. It says measure of angle DAB plus measure of angle CDA will be equal to what? So let's focus on these angles. When we talk about DAB, it is this angle DAB, this particular angle. And when we will add CDA, that is CDA, this angle, that is adjacent angles. When we add them up, it gives us equal to 180 degrees. This is another property that we have learned in this exercise 3.3. And the reason being adjacent angles are supplementary. And what is adjacent? Adjacent means the connecting angles of a common line segment. So for example, if we take this line segment, what are its common vertices? It is angle C and angle B. That is 2 angles formed at the endpoints of a line segment. For an instance, if we consider AB as a line segment, then adjacent angles would be A and B, because these angles are formed at the both ends of this line segment. That is what adjacent means. And by supplementary we means sum of angles should be equal to 180 degrees. Therefore, angle A and angle D will give us sum as equal to 180 degrees. Similarly, angle A plus angle B will give us 180 degrees. Again, angle B and angle C will give us 180 degrees. Finally, angle C and angle D will give us 180 degrees. That is, adjacent angles are supplementary. That completes our fourth part. With this, first question of exercise 3.3, understanding quadrilaterals, has been solved. Moving on to question number 2. Consider the following parallelograms. So we are given different parallelograms. find the values of unknowns x, y, z, where x, y, z are the angles which we have to find. Therefore, let's dive into first part. So here we have a parallelogram, namely AB, C and D. So we need to find measure of angle x, y and z. So let's straight away try to solve it, and we will use whatever we have studied so far till this standard and also in this exercise. So let's focus on angle y. We just studied in question number first that opposite angles in case of parallelogram are equal. Therefore, angle y will be equal to 100 degrees. So we straight away wrote y equals 100 degree, and the reason being opposite angles property of a parallelogram. It is understood we are talking about parallelograms because question has already said that we have to consider all of them as parallelogram. Therefore, we did not wrote it. We simply wrote opposite angles property. Now let's focus angle x. We just studied in question number first that alternate angles are supplementary. So angle B plus angle C will be equal to 180 degrees. So using same property, we wrote x will be equal to, if we subtract 100 from 180 degrees, the same has been written here, 180 degrees minus 100 degrees, it gives us 80 degrees. Therefore, measure of angle x will be equal to 80 degrees, and the reason is adjacent angles are supplementary. So we are just using whatever we have studied so far in previous chapters and standards. At last, we are required to find measure of angle z. So we have already found measure of angle x, and we know very well that opposite angles are equal, so we can straight away write as z equal to 80 degrees because opposite angles property, since we have found measure of angle x in previous step. With this, our first part of question number second has been solved. Let's visualize question number second. Again, we have a parallelogram. In all these questions, we are tackling parallelograms only. Only one angle has been given to us. With this help, we can easily find angle x because adjacent angles are supplementary. So again, we can write x equals to 180 degrees minus 50 degrees. This gives us 130 degrees, and the reason being adjacent angles are supplementary because addition of both these angles, that is angle x and 50 degrees, should give us 180 degrees. With this, we can easily find y because they are equal since opposite angles. So we straight away wrote y equals to 130 degrees because it would be equal to measure of angle x. And the reason being opposite angles property. Now here is a new thing. Angle z is outside this parallelogram. So how we could find it? Here, the concepts that we have learned in previous standard will be used. If you consider here, opposite sides of a parallelogram are parallel. So this side is parallel to this side, therefore represented with these two parallel lines. This means these sides are equal. Again, these sides are equal. Now, just focus on these two sides. Since these two sides are parallel, as represented with single crossed straight lines, here it is a transversal. And you know very well that this angle and this angle are corresponding equal angles whenever a transversal crosses two parallel lines. Here parallel lines are these ones, and this is a transversal. Therefore, we can write angle z equal to angle x, which we already found as 130 degrees. Therefore, the reason being corresponding equal angles. That completes our second part. Moving on to third part. Again, opposite sides are equal, so we marked with these parallel lines. Now let's focus on angle x. We have studied in previous standard that if two straight lines are crossing, they form vertically opposite angles. And this symbol represents 90 degrees. This square symbol represents 90 degrees. And these two lines are crossing each other. Henceforth, this angle and this angle will be vertically opposite angles. Therefore, measure of angle x will be equal to 90 degrees. Let's focus on finding angle y. We know very well that this angle is 90 degrees, this is 30 degrees. And we can easily find third angle by the sum property of a triangle. Therefore, if we subtract 90 and 30 from 180, we will be able to find measure of angle y. So you see, we are not restricted only to apply properties of a parallelogram. We are applying everything we have learned so far. Therefore, mathematics is a systematic approach where everything you have learned in your previous sessions is helpful in order to find your current problem. So we can write y will be equal to subtraction of 30 and 90 from 180 degrees. Therefore, it gives you 60 degrees. So we have successfully found measure of angle x and angle y. Now, let's focus on finding angle z. So if you observe again, this diagonal DB is a transversal to these parallel lines AD and BC. Therefore, we have a combination of angle as alternate interior angles, and we know very well from previous standard that alternate interior angles are equal whenever a transversal crosses two parallel lines. So if you forgot it, you must first try to visit the chapters from previous standards. With this, angle Z will be equal to angle Y, and the reason is alternate interior angles are equal. With this, third part is solved. Moving on to fourth part. Again, we have a parallelogram. Let's focus on finding. So these two are alternate angles of a parallelogram, and we know they are supplementary. So if we subtract 80 from 180, we will be able to find measure of angle x. Therefore, we wrote x will be equal to 180 minus 80 degrees. It gives us 100 degrees, and the reason being adjacent angles are supplementary. Now let's try to find angle y. Again, we have found this angle as 80 degrees. Now these two angles are supplementary because these are the angles on the same line segment. Also, if we do not apply that property, we can straight away find angle y as equal to angle 80 degrees because they are opposite angles, and we know very well that opposite angles of a parallelogram are equal. Therefore, we can find out angle y using any of the properties. So we wrote y equals to 80 degrees because opposite angles property of a parallelogram. Angle z, again, it will be equal to 80 degrees. Why? Because these two lines are parallel to each other and this is a transversal. Therefore, corresponding equal angles are formed. Therefore, angle z will be equal to 80 degrees, and the reason being corresponding equal angles. With this, fourth part has been solved. Moving on to last part, fifth part. Now let's focus on angle y. It can be easily found because it is opposite to angle 112 degrees. Therefore, we wrote y equals to 112 degrees opposite angles property. Now let's try to find angle z. So we know very well that adjacent angles are supplementary. That is, measure of this angle and this complete angle, that is 40 plus z, will give us 180 degrees. So we are given with two constants and we can easily find measure of angle z because all these three angles, that is 40 degrees, z and 112 degrees, will give us 180 degrees. Because again, this angle and this complete angle will give us 180 degrees. So if we subtract 112 and 40 degrees from 180 degrees, we will be able to get measure of angle z. So we wrote angle z will be equal to 180 degrees and we are going to subtract 112 and 40 degrees from it. So we finally get measure of angle z equals to 28 degrees, and the reason being adjacent angles are supplementary, that is these two angles. Now, well, if you observe, these two sides are parallel to each other because they are opposite to each other, and this is a transversal. This dotted line or this diagonal is a transversal. So again, we have a formation of alternate interior angles. So angle z is alternate to angle x. That means they both will be equal because it is a transversal to these two parallel lines. So we wrote measure of angle x will be equal to measure of angle z that we found in previous step, that is equal to 28 degrees from here. And the reason being alternate interior angles are equal in case of transversal crossing two parallel lines. So here we have observed that we just need not to apply the properties of parallelogram. We need to apply every property that we have learned so far. With this, question number 2 of exercise 3.3, understanding quadrilaterals, has been solved.